Welcome to The Explainer. Today, we're going to pull back the curtain on a piece of technology that, well, billions of us use every single day, most of the time without even thinking about it. It's a story of pure genius, incredible perseverance, and a legacy that was almost completely lost to history.
All right, let's just start with this. You know that little map in your pocket, the one with the little blue dot that tells you exactly where you are, guiding you everywhere? Have you ever stopped to wonder who did the really hard foundational math that makes that little dot so unbelievably accurate? Well, the answer leads us to this truly remarkable mathematician, Dr. Gladys West. Her calculations literally shaped our modern understanding of the planet. And yet, for most of her life, her absolutely essential role in creating the global positioning system was one of science's best-kept secrets.
So to really get a grip on just how huge her impact was, we've got to go back, way back. We have to understand where she started, because she came from a time and a place where her journey seemed, well, almost impossible.
So picture this. Gladys West was born into a sharecropping family, right in the thick of the Jim Crow South. She saw the tough, seemingly endless work on the farm, and she just knew, deep down, that wasn't going to be her life. She figured out really early on that her ticket out, her path to something different, was going to be education.
And you know, she actually wrote about this in her memoir. This quote says it all. This wasn't just some nice thought for her. This commitment was her driving force. It was the mindset that just propelled her forward against all the odds.
And man, was she brilliant. I mean, she didn't just graduate high school. She was the valedictorian. That earned her a full scholarship to Virginia State College, a historically black college. And she didn't stop there. She got her bachelor's and then a master's degree, both in mathematics. And that path led her to a job that, for the time, was pretty much unheard of.
And this is so important, you gotta get this. She was only the second black woman ever hired there, one of just 4 black employees in the whole place. So yeah, she wasn't just solving impossible equations. She was shattering these huge social and racial barriers just by walking in the door every day.
Okay, so that brings us to the actual work, to the giant scientific puzzle she was hired to piece together. And it's a really fascinating problem that stood between the idea of a global navigation system and, actually making it a reality.
So why was GPS so hard to create back then? I mean, you think, right? Just shoot some satellites into orbit and have them beam down signals. Easy. But no, not at all. Turns out there's this really fundamental problem you have to solve first, and it has to do with the actual, true shape of our planet.
We all have this image of the Earth in our heads, right? A perfect, smooth, blue marble. But the reality is, it's not like that. Not even close. It's actually what scientists call a geoid, which is basically a fancy word for a lumpy, bumpy, kind of squash potato shape. And because of those lumps, mountains, deep ocean trenches, gravity is slightly different all over the place. For a satellite zipping around the Earth, that's a massive problem. A tiny extra tug of gravity can throw its predicted path and timing off by just nanoseconds. And boom, your location on the ground is suddenly off by a mile.
And this is where it gets absolutely critical. For GPS to actually work, not just kind of work, but be accurate enough for guiding ships, planes, and crucial military assets, it has to be accurate down to just a few feet. And to do that, you need an unbelievably precise mathematical model of that lumpy potato planet. That was the monumental task they gave to Dr. West.
So how in the world did she do it, especially with the technology they had back in the day? Let's dig into how she, with her team, basically wrote the code for the entire globe.
Her process was just incredible. She'd get all this raw data streaming down from the earliest satellites. Then she'd program this absolute beast of a computer, an IBM Stretch, that literally filled an entire room. She wrote these super complex algorithms to account for everything, gravity, tides, all these other forces, and just kept crunching the numbers again and again to make the model of the Earth more and more accurate. And her work was so good, she got noticed. In 1978, they made her the project manager for a totally new, groundbreaking mission called CSAT. This was a huge deal. It was the very first satellite ever designed just to study the Earth's oceans from space. The data from that project, it was absolutely essential for refining that geoid model even further.
42. Just let that sink in for a second. 42 years. That's how long Dr. Gladys West dedicated to her pioneering work at the Naval Surface Warfare Center. A whole career of quiet, world-changing breakthroughs before she finally retired in 1998.
So for decades, most of her life really, her work stayed in the shadows, pretty much unknown to the public. It was all tucked away in classified reports and dense academic papers. But after a lifetime of these crucial contributions, the world finally started to learn her name.
And once her story got out, well, the tributes started flooding in. Her own home county in Virginia put it just perfectly, highlighting how her journey of talent and pure perseverance continues to inspire whole new generations. I mean, just look at this list. The Air Force Space and Missile Pioneers Hall of Fame, BBC's 100 Women, major engineering medals. In the last chapter of her life, she finally started getting the kind of recognition that puts her right where she belongs, among the true giants of science and technology.
And I absolutely love this little detail. After all that work, after literally helping create the foundation for digital navigation, Dr. West herself often said she still preferred the old-school reliability of a paper map. It's just perfect. It gives you such a wonderful glimpse of the humble, down-to-earth person behind the groundbreaking science. So, as we wrap this up, what's the big takeaway here? What does the incredible life and the hidden work of Dr. Gladys West really mean for us today? You know, her story really forces you to look beyond the official histories, beyond the famous names that we all know. It challenges us to ask a really vital question. Who else? How many other hidden figures are out there whose genius and quiet, dedicated work is embedded in the technology we use every single day? The world we navigate was built by so many more people than we'll ever know.